Thank you. So this is the erstwhile SDLC that we're all aware of, right? We would start with the requirements. Product manager has written a PRD. One of us goes into discussion with them as an architect and says, okay, what is the tech spec out of it? So we'll have some discussions. We will write a tech spec that contains not just the functional aspects, but also all the non-functional. How is it going to scale? How many concurrency do you want to support, and so on. Then we go into the design phase wherein we put our heads together, create an architecture diagram, high level diagrams. We've all done it. Then implementation, which used to be the longest leg of all. And then through the implementation, there is this whole process of line by line PR reviews that we would do. And then testing and deployment. Now, this is a cycle that we have sort of run through many years, and we have tuned to our best comfort.
Yeah, and today as I think about this whole conversation on AI, all of us are trying to map the generative AI work that we're doing in this SDLC because we know this has worked in some form, shape, and we are all very comfortable with it. So today, as we go through our talk, we are going to touch upon the aspects of where does this fit in the traditional life cycle and what parts it can do well, and how are we dealing with it today.
So we have structured this session in roughly 4 segments. The first segment, Bhavesh will come in and walk us through what do you do when you have a one-line requirement and how do you create a spec out of it. Bhavesh works with Moloco. And then the second segment will be done by Nitesh from Razorpay. He will take that spec and show us the journey of building it and then finally deploying it. And then the third segment is where we will see something that is in the works. When it breaks, how do you go ahead and find out what is broken and how do you fix it? And that Sathish will lead with. While these are 3 people who come from 3 different teams. For the purpose of this presentation, to keep a little bit of a cohesive story, we've built one seamless feature. It's a very simple feature, and Bhavesh will walk you through that in a little bit. The reason we've kept it simple is because we don't want to focus on the what. We don't want to focus on what we are building. We want to focus on the how part of it. And with that, I'll hand over to Bhavesh.
Thank you. Thank you, Sarika. Can everybody hear me? Okay, before I jump into actually building, I want to talk a little bit about the change that's happening all around us, right? And this is a little bit about what Sarika spoke, right? In the version of software development that I grew up with, and many of us in the room grew up with, the expensive part was building, right? We had design reviews, PRD reviews, planning, and then sprint, and then we waited for weeks and months for the feature to go live, right? We built this entire scaffolding to protect what was the most valuable resource, which is developer time, right? But now everything is flipped, right? Implementation is cheap. It's just easy to quickly try. So all that, process that was actually protecting that scarce resource of developer time, it was actually doing one more thing. It was asking the important questions. Is this the right thing to build? Is this the right thing for our customer? Is this the right evolution of our product? Did we build a dummy button before actually going and implementing the button? When building is cheap, there's very, very little pressure to go deep and understand that process. You can just start, and then those questions stop getting asked. Not because they weren't important, but because the forcing function that made us ask those questions has kind of disappeared, right? So building is no longer the bottleneck. It's actually clarity, and clarity has to carry a lot more weight than before. Now, let me talk about a very simple example, right? Eggs and heat, 2 simple ingredients. The outcome space is massive, right? The starting point tells you almost nothing about where you're going to land. And this is what AI does with vague intent, right? AI will take an underspecified input and very fast and very quickly produce a beautiful output. The danger is not that the output is wrong. Actually, the danger is it's right, and because it's right, we tend to accept it, right? A beautifully structured design doc can still be modeling the entirely wrong thing. I call it garbage in and confident garbage out, right? And this is the part that catches all the teams off guard, because when the output that arrives is fast, it's clean, there's a natural tendency to move on and accept it. But fast and clean does not always mean correct, right? Let me show you a simple example of how we're going to do this, and we'll move on to a demo, right? Very simple. We have assume a attendees page. We are all here attending music. Imagine I have this attendees page, and I want to build a very simple search and filter functionality. Okay, I'm going to walk you through a replay of a Claude session because I don't want to spend time waiting for you to come up with tokens and stuff like that. So it's a real session. It's just recorded, and we'll move on. I'm going to pause at various points in the session at the parts I want to highlight. Right. So let's start it. I'm using an open source skill. We can talk more about this later. So this is the prompt, right? Add a search and filtering capability to the attendees page. Just gave an approximate number, and I didn't give anything else. No layout spec, nothing, right? So as usual, the AI immediately came up with a few options, right? And it said, hey, I would like to come up with a few visual outlines. And this is what I was talking about AI, right? It's fast, it's cheap to start building options very quickly. So it automatically came up with these options saying, hey, there's an option A, there's an option B, and there's an option C. And this is where it felt interesting. I immediately pushed back and I asked, why not A and C? Right? I would like a combination of both. But AI is programmed to ask you binary questions and move on. Right? So I had to push back, pick something that seemed like the better of the combination of the two. And this could be for multiple reasons. It probably didn't go through the code base, looked at other areas. But eventually then it came up with a great option after this, where it used a combination of A and B. Now, in this process, the AI didn't get smarter. It's just that I pushed back when it didn't feel right or it didn't feel complete. Okay, let's continue. We moved on. We discussed the data model a little bit. AI immediately suggested, hey, this is great for a client-side filtering project because you have about 700 attendees. Just load everybody and use the filtering on the client side, which kind of made sense. But then I asked a little bit more about search, and this is where you can use AI as a sparring partner as well. And one important question I asked them is, what if I want to integrate this search API with somebody outside? Of course, we are building this on our conference webpage, but I can imagine this, technology tribe community to go very big, and I'd want to integrate it very places. So again, I asked about external integrations, and then this opened some conversations about client server and a lot of other areas. So I added a constraint which the AI clearly had no way about knowing. Right? I asked about external integrations. We went and revisited this older discussion. And it came out because I kept pushing back, right? And this is the part that won't show up in the output, right? Because all the product context, AI has no way to come to know. And product vision does not live only in the doc, but lives in the minds of the people who are building it and working on it day or day out, right? So we continued this, we kept on building it, we discussed a few other functionalities. Imagine we are almost done here. And then I was, to just show you where we were at this stage, we were here. I was obviously not, excited about this yet because I didn't like this checkbox like year of experience slider. So I pushed back and then I said, why can't we do like a slider? Like I would like everybody, and I'm showing this form because all of you have entered data into this, so you're a little familiar. But like, why can't I have like a slider, right? And AI immediately came back with, hey, all your data is actually bucketed. So a slider doesn't make a lot of sense. And this is because, I then pushed back and had to ask like a very important question on, what if I start getting data from LinkedIn instead, right? I can start getting the data over time from LinkedIn because everybody's LinkedIn profile is there. And this is another thing that, I am thinking as a product developer, and AI is obviously not going to think about it. It looked at the data, it produced an output that worked for the data, and it moved on. Right. So by asking this question, I may have spent maybe one or two more prompts, but at the end of the day, it saved, potentially a future migration because now the output was an updated interface for min and max years that can fetch even dynamic ranges from other sources. Right. So at the end of this whole process, we immediately came up with a very detailed spec, which I'm going to hand over to Nitesh and talk about more. But it clearly came up with a spec on what needs to be built, how the slider needs to be built, what components need to build. But I want to touch upon a few more things before we get there. Let me just skip the demo slides. Sorry. Okay. 3 decisions. At each point, AI was ready to move past, and each one felt worth stopping for, right? And all these decisions just made the entire output so much more better, so much more extensible. And the spec that I shipped is not the one that AI produced. It is what we arrived after multiple times and iterative pushback. And that gap is the actual work. That gap is what gets missed easily when teams start accepting the first clean output they see, right? And this is what I want to talk about, right? AI has a pattern of creating, closure. It wants to move on to the next one. It produces options, pick, move, close, move. And you start feeling very productive until it actually isn't. As humans, all our design work and thinking is more like that messy pattern on the right. We think recursively, we hit dead ends, we go back 2 steps when something doesn't seem right. The trap is actually accepting the clean output because it looks complete, right? We saw that with the year of experience slider. And AI is very good at moving forward. That's also its limitation. The skill is actually not in prompting, and it is actually knowing when you want to resist that momentum of going forward and ask the question the agent already considers complete. Awesome. Back to you, Shilpi.
Thank you. Quick questions, Bhavesh. You were using something beyond the prompt, clearly. What was it?
Yeah, so there are multiple open source skills available. I was using Superpowers, which is a very popular open source skill, and that skill is designed. I was using the brainstorming skill within that, functionality, designed to just give options, pick something, move on, present trade-offs, and then present a spec. So there are multiple ones like these in the market.
Okay. And I noticed that you showed that cluttered diagram, but eventually, if I think about the typical SDLC, people are very used to what we call the three amigos process. And for people who don't are not familiar with that term, the product, the tester, the engineer, brainstorming, doing the discovery process. What does it mean in AI?
Yeah, great question actually, and I think of this as very good parallels with us, right? Even in our design review process, right? The person who's writing the design and who's reviewing the design, the first design reviewer and the second design reviewer, are all at the end of the day having the same skills and functionality, which is that of a software developer. They're just wearing different hats in that process. So I imagine a world in which we start codifying, all of these into agents and skills that will run. That will, there'll be this, like I use this agent to brainstorm and come up with a spec. I can think of other agents that is a reviewer spec that checks, hey, is it actually covering all the use cases? And one that is, oh, is it fitting our enterprise pattern and knowledge base and stuff like that. So I would think of us codifying all these into different skills, the various skills we put on as developers and reviewers.
Interesting. We'll continue with the questions later. I think Nitesh is waiting. Yes. Let's get started with him.
Awesome. Thank you.
Thank you, Bhavesh, for building. Am I audible? Am I audible? Yeah. Thank you, Bhavesh, for building the great spec. I wish we all get such a great spec in our job. We don't get it, right? Yeah. So, but before we move with the implementation, I want to ask something. How many of you have read about a news where AI has deleted complete production database of a company? It's on everybody's LinkedIn feed, right? How many of you know about AI exposing secrets into public? Right? All those are popular examples where we all are getting about, right? So imagine scenario where a car running on this kind of road without any guardrails, no safety rules or anything. We all know what might happen with this car, right? Or it might be, say, AI-driven autonomous car. It might even be worst in this kind of road. Exactly same happens when we use AI without any guardrails, controls, and proper safety checks. But we all know about guardrails, right? I mean, everybody is talking about it aloud for a long time. But why do we still make mistakes? I feel we make mistakes because we do not write guardrails and enforce them properly. Sometimes we simply put them in a prompt, or we give very vague commands like don't execute dangerous commands or something, right? AI doesn't know what does dangerous mean. What call commands qualifies in this particular category. So I made an attempt. I tried to create a version of fairly good guardrail. So if you see here, it's our guardrail should mostly cover all the important points which allow AI to work safely without any ambiguity. Right? It should very clearly talk about safety and security, what not to do. All the guardrails would mostly have what not to do, right? Do not run destructive command, and we are also giving the examples here, say DB drop. So if that company had this kind of guardrail, AI would not have deleted the databases, right? It should talk about code integrity. Most importantly, it should also talk about the architecture boundary. Not all the features are equal. Sometimes we build greenfield, brownfield features, right? It should very clearly tell AI or LLM how to handle those kind of features. Right? It should also give very clear instructions about those. And one of the pattern which I have seen that skills doesn't automatically inherits the guardrails which we include. So we should also tell very clearly how skills will work. Generally, people will install hundreds of skills in their machines, right? We need to give guideline like when to use which kind of skill and how to use it. You can also specify the priority order for LLM to work on, like always check for security, guardrails, and then finally go for the user intent and the workflow, right? So I worked on this. I built this guardrail using the help of AI only. I didn't invented it. We can use AI or LLM as a judge and iterate with it so that it removes the ambiguity and it can further ask us question to enforce proper text there. Practically in an organization, we will have multiple set of guardrails. Some would be organization level, which can contain the policies at organization level. You might have different guardrails for different projects in the teams because every tech is different. Maybe for data pipelines, for microservices, you might have different set of guardrails. And right, so we will have, and even for the domains, right? If you're in payments domain or some other, you might have different guardrails for those. So since we have seen the guardrails now, let's talk about the development workflow. Bhavesh already briefly touched about we are using Superpowers agentic workflow. This is an opinionated workflow, open sourced on GitHub. It gives curated skills for all the standard SDLC lifecycle, right? So we can, I won't deep dive into it further. We can go and check on this one. Now we will create a plan. So we have received a spec from Bhavesh already. In real world scenario, we will go and review the spec and see whether it covers all the use cases or not. And then we might have back and forth conversation around that. Assume that spec is written very properly. Then what we are going to do, we are simply going to initiate our AI agent and ask it to generate the plan using the spec. If our spec is pretty big, we can also ask it to create multiple plans so that it divides the problem into smaller chunks. And you can see here, right, LLM is stuck here in between. It went into overthinking because my guardrails were not enough. It went into overthinking and it was deciding to figure out some answer. Then after a few interruptions, it moved ahead and created a plan here. So let's look into a plan which this is generated. So if you remember, our objective is to implement search and filter capability on top of our existing page. So this around 40-page spec which we have received from LLM, and the important point to read in this, right? I mean, one of the problem with this spec is these documents looks very beautiful, and we can confuse it for the correctness, right? So we need to very specifically give a lot of thought here. We need to look into what is our goal, what kind of architecture we are implementing, what is the tech stack, are we adding any new dependency? We need to deep dive further. It divides everything into smaller tasks. So before AI era, when we used to work, right, like real humans, right, we will divide our task, team lead will divide the task, assign it to the people, right? So it is actually trying to do the same. It creates the task. It actually creates the test cases. This follows the TDD approach. It will create test cases and everything, expect failure, then update it. So in this spec, we should definitely look for our database queries, our transaction boundaries, our test cases, any critical business logic. And once we are satisfied it, then only we should move forward. Right? Once our spec is generated, now we need to simply go for the implementation. As Bhavesh mentioned, right? A lot of things are shifting left. We need to focus more time on reviewing the spec and the plan rather than building the code. Now, since our spec is very detailed, plan is very detailed, now AI agent can write the code from here. We can see it has committed the code and then finally created a PR. Now, it also does what all things it is already validated in the PR and what all things are pending to validate. Once PR is raised, this is another important point, right? Even though we have reviewed the spec and the plan, we haven't written the code ourselves, right? And so we have little bit of distrust on the code which is implemented by the AI. Then we need to definitely spend some time on reviewing the code. As we can see here in this, this is trying to figure out the differences in the code. It is asking us what code was implemented. So once we provided the spec and the plan, then this goes and do the review of the code. The important point to look into this, it obviously checks all the test cases. It checks for if we have touched any older code, because this is a brownfield feature. Are we doing scope creep here, right? It validates all those things and also gives the issues around it. In practical scenarios, we will complement it with our security or static code analysis, all our security stuff to validate before we gain confidence on this one. And once we are satisfied with this, now we just merge our code and CI/CD kicks in, and we finally get our page which is deployed. So to save the time, we had taken all these things. And if you remember one of the example which Bhavesh talked about, right, this slider thing, right? So all those things are implemented in this. Yeah. So after this code is deployed into production, and we have delivered our objective here.
Only to introduce some bugs that Satish will talk about.
Yeah. Quick question, Nitesh. I did notice that you had this brownfield thing in your guardrails, but it's a very interesting question, and I think relevant to many people here. Typically, brownfield requires a lot of context, uses a lot of token, and that's one of the other worries, right? So, are there other techniques to get the context for brownfield, RAG, graph DB, other things?
Yeah, so I think so. This example was pretty simple because we're the single repo and we are building feature on that. In reality, you will have multiple repositories, maybe thousands of repositories in your organization, right? Now you want to add a feature. Now, first thing, whenever you are doing the brainstorming, also writing the spec, agent need to know where you want to add certain feature, what all things get impacted, where else you need to make a change to in what all microservices, database scripts, and everywhere you need to make a change. So we need to have a knowledge graph, definitely. So I've seen the transition, building the RAG, using the semantic search kind of database, indexing everything. It didn't work out well. Then later we moved into converting every repo agent ready, where we put agents.md file in every repo, which contains the context of that particular repo, and having an agent which at very high level knows the structure of the organization, which domains have what all microservices, some information we need to see it, so that that agent can go and discover the things. So I think that particular approach worked well. So during brainstorming, it can go scan the repositories and figure out the dependencies. It's token intensive, but that works pretty well.
Can you cover one thing that did not work in this trial?
Yeah, so I mean, before doing proper guardrails, right? So I had one example. So I was working on one of my toy project, right? So I had to implement a feature to fetch data from backend on the mobile app. And without these guardrails, and I didn't review the plan properly, and AI implemented a feature where front end was continuously polling the API, and that brought down my server. So important point is we need to read the plan completely. Yeah.
Yeah. Yeah, that makes sense. We will talk to Sathish and see what he's done.
Yeah.
And then we would love to have you back for some more questions.
Thank you.
Hey, thanks Nitesh, thanks Bhavesh. So now that we've seen how to build and deploy features end to end faster using spec-driven development, let's see how AI can help us beyond code generation in things like debugging production issues. So what we've done is we built a like in the past two sections, we built a feature for search and filter, and we've added features like search by company, search by experience, and all these features. So we thought, why not add another feature for searching attendees by past companies? Like we all want to find out like who from our past companies are attending the conference along with us and speak up to them, right? So we built this feature, and using the exact same methods that Bhavesh and Nitesh showed for spectrum and development. So we are able to search by past company. We are able to add more past companies and search by even multiple past companies. But unfortunately, we also broke some existing feature. The existing feature for searching by current company is now broken, and it starts showing up 4xx errors when we try to hit attendee search, right? And this is because of a schema change or a contract change. And the traditional way to debug this is to go to your metrics dashboards where you can see spikes in your error metrics, or you can see an aggregated increase in your error logs, which are the traditional ways to debug. Let's see how AI and its agentic systems can help us in debugging and troubleshooting this issue in a better way. This is a representative simple application where there is a front end, there is a backend service called attendee service, which calls another backend service called attendee search service. Translating this to a real world scenario with hundreds of microservices will require a lot more tools and skills than what I'm about to show now. So before we start debugging with AI, let me just describe the setup. So before the setup is an agentic system, a coding agent like a Claude Code or Codex. It has certain MCP servers that are configured. In this example, I've defined like two MCP servers. One is a Prometheus MCP server in mcp.json, and the other is a Loki MCP server for connecting to logs from Claude Code or Codex. And one quick way to verify that you have the right MCP servers configured is to just do like /mcp command in Claude Code or Codex and verify that all the tools are loaded and the MCP server is also connected. The second important part of the setup is having the right set of skills. So we've created these skills from scratch by following a debugging workflow using Prometheus. There are also open source equivalent of these skills, but it's easier to customize the workflow if you start writing the skills from on your own. So on the left-hand side is a metric analyzer workflow. It uses the tools that are exposed by Prometheus. Prometheus exposes 10 odd tools, and there is a custom debugging workflow that is configured here. So the skill is acting as a recipe for us to orchestrate our debugging workflow. Similarly, on the right-hand side, there is a log analyzer skill. This mentions a recipe using low-key logs, low-key tools in order to grep for error logs, grep for exceptions, and try like grep for a service-specific log and try to find out what is broken, right? Like most organizations don't just use standard 2 or 3 monitoring tools. There'll be a lot more monitoring tools which are nuanced and specific to your organization, like something for service fault localization, something for front-end error metrics and whatnot. So one way to connect all that is we have a third skill, which is like a glue skill here. It's called incident debugging skill. This is like a workflow orchestrator skill, which combines the other two skills uh, and mentions an Uber workflow which specifies how to use metrics, how to debug using logs, and triangulate across these multiple sources. So for a real world production system, it's easier to imagine like how you'll add more things like service topology graphs, how you'll add a distributed tracing system or your own config management system or Sentry like error tracking system to this, right? So once we have these skills set up, it's easy to verify by just doing /skills or just by asking the coding agent, what skills do you have? So in this case, it has loaded the incident debugging skill, the metrics analyzer skill, and the log analyzer skill. Let's go through an example of how to debug using these skills in MCP servers. I have a recorded Codex session here, which I'll just walk through to explain how AI is able to debug this issue. So we can just start with the debugging prompt, which says something like use the incident debugging skill to debug the issue, and just put the plain text description of the incident or the issue. In this case, we are just saying attendee search with company has started failing with 4xx errors, and how do you debug this, right? So the agent starts by loading the skills that matter. In this case, it loads the incident debugger skill. And incident debugger happens to refer to the other two low-level skills, which are metrics analyzer skill and log analyzer skill. These skills are loaded on demand or lazily by the agent, so they are not going to eat into your context window when you're doing something else. Like for example, when you're doing code generation, these skills are have no role to play, right? And next, the agent tries to understand the ecosystem, like in terms of metrics and logs, it tries to understand the ecosystem using the metadata that is available. So it'll try to find out what are the different metric names that are available, what are the different low key labels that are available, so that it can filter by service, filter by environment, and whatnot. And it'll like for a real world system with thousands of metrics and hundreds of services, we will still need more sophisticated tools to drill down to the right metrics to hint the AI agent in terms of how to grep for the right logs, right? So in this case, it is trying to probe the system, and after it probes the system, it has narrowed down to a couple of metrics. For example, one of the metrics that it is trying to run here, in case it's not visible to you, it is trying to group all the HTTP requests by their route and by their status code. It is sort of like a human walking through a dashboard and trying to find out which specific API is failing. And it's not just looking at RPS here. It'll also go ahead and look at something like what is the error rate grouped by URL, grouped by status, so that it has a holistic idea of what is wrong and what is breaking. It'll run very similar queries for logs. It'll grep for which URLs are broken. It'll grep for what kind of error code those URLs are returning. For a real world production system, obviously it cannot grep all the logs. So it has to grep the logs, aggregate them so that scale does not become an issue for the agent to debug. And it's not just trying to triangulate between metrics and logs. It also tries to reason about the code. Um, So there are two ways to run ops CLIs like this in production. In production, you can either start it on a blank repo where it has no context of the code, or if you have high confidence about which service is at fault, you can even start this on the repo which is at fault, right? So in this case, it tries to look at the exact code files. It opens up things like attendee search.ts and app.ts to understand which code snippet is the one that is causing the outage. And in the end, it comes up with a root cause in a specific format. The incident debugger skill is instructed to come up with root cause in a specific format like this, right? So it'll say this is the impact. The API for attendee search is returning 4xx. And in terms of evidence, it's able to say that I'm finding 4xx errors on this specific attendee search API. And in terms of logs, it says I'm seeing a repeated log message called unknown filter field for company. And it also comes up with a high probability root cause. It says the high confidence root cause is that there is a schema mismatch where the old contract specifies user.company while the new contract specifies user.work.current company and user.work.past company, right? So the AI has triangulated across metrics, across logs, across your code changes, and then it has come up with a root cause. Uh, it has not just stopped at the root cause, it's also able to suggest a probable fix. Like it suggests that you have to change in the front end code and the service code from company to current company. Like if you probe further, it can even generate an auto fix PR and share that PR with us. Like another good use case of UI post code generation or in the operations world is a grunt work that engineers have to do in terms of generating a post incident report, fill up incident timelines, impact, and what went wrong, right? The most high cognitive work there is filling in business impact, customer impact, and five-way RCA, whereas the rest of the work can easily be automated by using some sort of skill here, which will generate a post-incident report according to a template. It can even be connected to your actual investigation sources like Slack channels and Zoom meeting transcript notes to gather more details and generate a more descriptive post-incident report. And this becomes like an end-to-end cycle, right? Once you start capturing the action items and capturing the root causes this way, you can start referring to them at a later stage in order to learn from past incidents and fix recurring incidents faster. This is a typical AI for ops stack that I've used in this demo. It consists of a three-layer setup where the first layer is the agent. The second layer is a set of skills, which is a combination of skill code, skill prompts, and resources. And the third layer is the MCP server and tools. And finally, the last one is the data layer. And the engineer or the SRE engineer can come to a coding agent and ask, attendee search XYZ is breaking with 4xx errors. How do I debug this, right? And the coding agent will use the set of skills here, like the skills that we've demonstrated, like metrics analyzer, log analyzer, and incident debugger. This is a chance for us to not just use out of the box skills and MCP servers, but also put in company nuances. Like a specific org could be using a combination of monitoring tools and internal platforms which are supposed to be used in a certain way. Those can go in as skills or even in the form of code, in the form of custom MCP servers. This connects to out-of-the-box MCP and custom MCP, and finally talks to the data provider layers. Yeah. Yeah, that is the overall view of how AI can help us even beyond code generation into the ops world.
Satish, quickly, what has been the most high value and low risk area that you implemented AI for SRE?
So one of the most high value areas that I have seen is in a large ecosystem with thousands of services where each service is deploying tens of changes a week. AI can help you in sifting through all these changes and ranking like top K root causes and helping the human agent filter further. A human doing this manually would require a lot more effort compared to AI doing it, right? And the other area is in terms of alert reduction. When it comes to an alert, an engineer or a team exactly knows which service is the one that is causing it. So an ops CLI like this helps them debug with code context and get to the like fixing the alerts and fixing the noisy alerts faster.
Okay. Okay.
I wish this skill was available 5 years ago when I was at Flipkart. Can't tell you how many RCAs I had to write in the pricing and promotion system. Um, yeah, so I know, I'm sure you all have seen these blog posts which says, oh, I have so many agents running in the fully autonomous mode. I'm shipping things left, right, and center. And now with these guys saying it's there, right? They are generating the code, they are doing the incident fixing. I'll tell you what my mental model at this point is. And I want to go back to the autonomous car that Nitesh talked about. In my head, it's that autonomous car. It runs really well if you put it in a parking lot. Low risk, no complexity. So if you're doing, let's say, your test generation, if you're doing your demos, works wonderfully well. Or it works in a space where there are lanes and people follow lane discipline, which I'm assuming is the case for companies like Claude. When they say Claude was built using Claude, I'm assuming that's what they mean. But most of our production systems, unfortunately, very like the roads of India, have no lane discipline. Forget about lane discipline. We don't even have lanes marked. And that's what our production systems look like. And I can't imagine an autonomous car running in Indian roads for many years to come. That's my mental model. When I say lane discipline, this is what I mean by the lanes, right? All of your guardrails that we talked about and different people talked about in their segments, your acceptance criteria, your guardrails and understanding, testing. These are the lanes that you need to build to be able to let this car run on your roads. Build these guardrails and then you move on to using these tools because they are super powerful, but at the same time, you have to tread with caution. And specifically, when it comes to some of these areas, you have to be even more cautious. These are sensitive, right? Whether it is your secrets, like Nitesh mentioned, security sensitive changes, anything that is to do with your business critical decisions, which can have an impact on your top line, bottom lines, right? All of these areas you have to be super cautious of. We are not saying don't use them. Use the tools. They can really make you productive, but use them with caution, with the human control. And then raise the quality, build these lanes. And most importantly, I think it's this last one, and Nitesh touched upon it briefly. You have to define some standards so that you can move from, oh, I have these two engineers in my team who work wonderfully well and they've become productive, to can I have whole of my team become productive? This is the difference between that. Next. Yeah. So at this point in time, like this has been our observation. We've been talking to a lot of people, we've been having a lot of meetups in the last few months, that the teams who are moving, they are moving because they're building the AI systems. What we built, showcase today, this was all built from conceptualization to actually implementing it, recording the demos within a few days. And this is the team behind it who were not on stage today, who worked really, really hard. With that, I'll call everybody on stage. We will get into some question and answers.
Not rapid fire, but some questions. Okay. Please take the center stage. All right. So I think, there are a lot of interesting questions, but I am guessing that in the heads of people, at least based on the questions I've heard in the past, is everyone is on a journey. Where are you with your journey in your organization? What have you done and how did the journey look like?
I can go first. Um, in Moloco, yeah. Firstly, the journey takes time. I think everybody should know that. It started off very organically. There were a few champions who started playing around with it, and then that started growing into like a movement, and everybody started showing off their skills. Then the company built a task force around some of these people and started investing in common, like kind of areas to help developers and people move forward. So I think we are still at that stage where we are using AI as a support partner. We are not like given every control over to AI, but I think we're trying to figure out how to unlock, increase productivity. Oh, sorry. Point should land twice. So yeah, it's increase productivity. So I think for example, all the code that's generated today is automated by AI. But the other that interesting part that happened, especially at Moloco, was data access and data democratization. So all our non-technical functions started getting access to, hey, why is this happening? Much easier, right? We are in the term of ad operations and we have advertisers asking, why is my campaign not working? We built enough agents to build intelligence over the layer that you don't need product analysts and data scientists to do at least the first 5, 6 levels of deep dives.
Yeah. So for us, journey was started around 1.5 year back, and people started experimenting, and there have been multiple failure in between. So majorly the approach was people got access to all the tools, all the AI tools available, Codex, Cursor, then later CloudCam, and people experimented a lot. People build variety of skills. Somebody built a skill just to change the laptop's wallpaper. So people were building muscle memory initially by playing with the AI and skills and everything. Eventually, they started seeing the use cases in their particular domain. And people build a lot of automation, whatever on-call supports they were doing manually. People build skills. So at Razorpay, we have got hundreds of skills repository now. We have built our own workflow for all the agentic development, and now people can even use the sandboxes for the development. Just trigger your requirement to ticket through Slack, and backend worker and sandbox will do the development. You don't need to be in front of your laptop. So it's maturing. Yeah.
Is it standardized though, or is it everyone just contributes and picks up whatever?
No, so uh, it started as everybody is doing something their own, exploring. Then eventually, whatever fits well survived, and other things was not taken forward. But for all this thing nowadays, we have got a lot of open source tools like OpenSWE from LangGraph, etc., which gives a lot of these automations inbuilt. Even we talked about superpowers, which is pretty good tool, which gives that. Like this, we have maybe 20, 30 open source agentic frameworks available. I think we need to experiment and figure out which works best for our use case or extend it for our organization.
What have you heard, Sarika?
I'm working with multiple teams. I think the teams, different teams are in different phases, but pretty much everybody is taking a very, very similar road, starting with exploration, trying out different kind of things, building that muscle memory, which is important, right? The early exploration is not about building the right thing. It's about building that muscle, how to work with AI, where to keep control, what to let go, and then graduating from there to standardizing some of the SDLC aspects or some of the non-developer productivity. One place where we're definitely seeing benefits is the low risk areas, right? Whether it is like we talked about a lot about lane discipline, right? How do you build those lanes? There was a time when writing those test cases used to take so long, and now it's become super easy. So those are the kind of areas where we're definitely seeing wins. But at the same time, like everybody here mentioned, it's a journey and people are at different phases. One thing I do want to call out is that this demo is not a prescription in any way, right? What we've showcased is essentially different kind of aspects that you need to think about in your SDLC. But think about these aspects. That has to be your takeaway, and not really what Bhavesh did. That not the process.
Sathish, what about your organization?
What we have seen is that we internally are still exploring spec-driven development base and how it can help us. We are also looking at how close it can get to the current state of things, right? like we internally have something called an epic way where we do spec-driven development, but the output goes into Confluence, and we can comment on the Confluence, and then the AI agent can act on the human comments, right? So we built such workflows. And in terms of ops, our journey goes back beyond 6 to 9 months, where every team has something like a ops CLI, which is where we don't wait for all these observability companies to launch MCPs. We build our own tools and functions using that so that we can start like reducing alert fatigue, or like directly do an alert investigation report, send it to Slack so that the on-call load reduces a lot more.
How long have your company been on this journey?
In terms of ops work, I think it would be more than 6 to 9 months. In terms of spec-driven development, it's pretty new, like maybe like 5 to 6 months. Yeah.
So what about yours?
I think since a year and a half, folks have started playing around with code. And I think now we are trying to figure out how to standardize, centralize, and also build AI products out for our customers.
Year and a half
Exactly.
for us, yeah.
1.5 years.
Yeah.
Wow.
I think we've caught the people who are slightly ahead of the curve to present their work, right? We would have loved to get questions from audience, but unfortunately the time is up. We are all around. After